Okay, hello everyone. This is first video of for the lab 3. We will have other videos too. I guess in total we will have 3 or 4 videos. So this is the video for the first part. So in this lab, what we are going to do is that we will practice programming the conditional statements in assembly language. And by conditional statement, we mean how we can program the if-else statements and the for loops in the assembly language, right? So the hardware which you need for this lab is listed here. You need Arduino Uno board, you need a breadboard, you need a yellow, green, and a red LED. You need three 220 ohm resistors, four male-to-male jumper cables, and then you also need the USB cable for charging and data transmission. So as I said that in this lab we are going to work with the branch instructions. So I will highly encourage you to read all this background text which I have placed here. It is well written and it easy to understand. But I cannot go through it all of it in the video, but I can just quickly tell you that let's say if we want to encode this high level C code in assembly language, how can we do that? So let's first have a look at the C codes. We are saying if a value of R18 is less than R19, then enter the if block. Otherwise, don't enter the if block and do something else, our remaining program. So how we can do that? We can put the values which we want to compare in the first, we can load them in register R18 and R19, and then we can say, okay, compare R18 and to R19. So after comparison, we are using another instruction which is branch if same or higher. So here we are basically saying if a branch, if the value of branch to this label, if the value of register R18 is same or higher than the value of the register R19. How this branch instruction is working in detail, I have explained it here. Please read this text. I can not go through it in the video. So what will happen that if the value of R18 is same or higher than R19, then we will go to this point and start executing the remaining of the program. Otherwise, we will execute this part, do something part, right? Now, if I compare this code with the equivalent C code, here we are saying if R18 is less than R19, do something here. Uh, enter the if block. But here we are saying if R18 is greater than or equal to R19, then go to the label. So which actually we are basically saying the reverse of this. Here we are saying if R18 is less than R19, go to the if block. Here we are saying if R18 is greater than R19, go to the remaining program. So the condition you normally code in the normally code in the assembly language is reverse of the condition you encode in the higher level language. For example, here we are saying if R18 is less than R19, but here we are saying branch if R18 is greater than or equal to R19, but then branch to the remaining program. So both are correct, functionally correct. Only these are two different ways of saying the same thing. Okay. So okay, and yeah, so this is like a quick overview of how this branch instruction works, but this is just one example of branch instructions available in the assembly language of the AVR microcontroller. There are also other branch instructions which we are going to use in this lab. For example, branch not equal. So what it does is that, so this is like how we use it. So for example, let's say we say decrement some destination register, and then we call the instruction branch not equal label. So what does it means? It means branch to the given label if value in the destination register, which is operated on by the previous instruction, decrement if the value of that register is not equal to 0. Another example of branch instruction is in this code snippet where we are saying compare two registers RD and RR, and then we are saying destination register, source register, and then we are saying branch less than label. So here we are saying branch to the given label if after comparing two registers in the previous instruction we found that the value of RD is less than source register RR. Here is another example. Again, we are comparing two registers and then we are calling the instruction branch equal label. So here we mean branch to the given label if the content of the two registers compared in the previous instruction are equal. Sorry. Okay, so in this lab, we are going to set up our hardware in the way shown in the figure. And here we are connecting the red with the pin 8, uh, green LED with pin 12, and yellow LED with pin 13. And for those of you who have never before used the breadboard, let me explain just to give you some information about the breadboard. So first, here you see plus and minus signs on the top and also on the bottom. So all of these lines, like all this first horizontal row is short together, which basically mean that if you provide the high voltage on this point, you will get the same high voltage also on this point. And normally you connect the high voltage at this in this first location. The next location where it shows a minus sign is for the low voltage or the ground, and all of these dots, they are connected together. So if you provide the ground voltage here, the same ground voltage will become available here also as well. Same goes for this plus and minus sign on the in the bottom. Other than that, you have uh, dots between these top and bottom power line and ground line. So these dots, they are actually also connected with each other. So for example, all the dots in this column one, and they are all shorted together. So it's mean that they are connected with each other. However, these dots, they are connected with each other, but not with the dots on the other side. So in the middle you see a space, so it actually means that there is a break. So these dots are connected with each other beneath, but they are not connected with the dots on the other side of the bridge or the break. Okay, same goes for all other dots in the columns like 1 2 3 4 5 and so on, right? So all dots in column 1 are connected with each other, but not those which are on the other side of the bridge or the gap. Same goes for column 2, 3, and so on. And this is the way you are going to connect your LEDs. One more thing you want to keep in mind is that LEDs, they have positive and negative. They have two legs. One is known as a node and the other is known as cathode. The positive leg is known as a node and the negative is known as cathode. But how we find or identify which one of those legs is a node and cathode? Just by looking at them, the leg which is longer in size is a node on the positive side, and the one which is shorter in size is cathode. So when you are making these connections, make sure that you connect the cathodes or the negative leg, which is basically the shorter leg, to the ground here. So here we are connecting the yellow, the cathode of the yellow to the ground, the cathode of the green LED to the ground, and cathode of the red LED to the ground. And this black cable actually is connecting our the ground from the Arduino board to the breadboard. So all of these LEDs are then connected on the cathodes of all these LEDs are connected to the ground, which are cathode mean the shorter leg. The longer leg is positive or a node, and we are connecting those shorter legs with the 220 ohms, the 220 ohm resistors. And then on the other side of the resistor, we are connecting them, the yellow one with the pin 13 on the board, the green one with the pin 12 on the board, and how to say, the red one with the pin 8 on the board. Okay, so I also encourage you to read this, why we need transistors to connect LEDs with Arduino pins. I don't want to go through this text in the video, so you can read on your own, right? Uh, uh, what else? So what we are going to do in this lab. So that was basically background and how we are going to set up the hardware. But what we are going to do is that we are going to implement this table. So our program, it will read three values from the users: the gender of the person, the age of the person, and the fat percentage, right? So let's say if the gender of the person is male and the age is between 40 and 59, both 40 and 59 inclusive. So, and the fat is less than 11, fat body fat percentage is less than 11, then we will glow the we will blink the yellow LED. But if it is greater than 11 or equal to 11 and less than 22, then the green LED should go on. And if the fat percentage of the person is greater than 22 and greater than or equal to 22 and less than 28, then red LED should blink. But if the fat percentage of the person is greater than or equal to 28, then all three LEDs should blink. So this is the program how we are going to this is this is the table we are going to program. And remember, like there are different values for gender, male and female, and then both for male and female we have three different ranges of age ranges, like 20 to 39, 40 to 59, 60 to 79. And then based on their fat values, fat percentage value, we will blink an LED. Okay. Again, read all this material, and then you will understand what you need to do by the end of by the end of the lab, what task we need to implement. Okay. So let's go to the task one. So in the task one, what you need to do is very simple. You need to go to the lab 3. You need to download these files. Simply open a new sketch and add these files consisting of these. So you have a new sketch consisting of these two files. And then what you need to know, I'm skipping these 1, 3, and 4 because they are trivial steps. So after that, what you need to do is simply compile and run your code. So let me open this project. I have already downloaded and created the sketch. So this is lab 3A. So let me first go through the let me first go through the code. So here what we are saying is actually this code is same, almost same, which we have seen in the previous lab, which is lab 2. So here we have this function defined for reading 2-digit value. It is exactly the same function from the previous lab. In the setup function of the data INO file, we are simply setting the baud rate of the serial port, and then we are repeatedly calling this read 2-digit value function 3 times to read gender and then display what the gender is read, then read the age value and display it in the on the serial monitor, and then read the fat value of the person and also display it, right? And in the loop we are doing nothing. We are simply saying put the delay of 20,000 cycles, and then after that print a star, right? The other thing is, like, here we are using these variables age, fat, and gender. So these variables we are telling the assembler that they are defined in another file, but you are allowed to use them. And where they are defined, we have defined them in in the assembly file fat monitor underscore a dot s. So this file is very simple. We only have a data section, and in the data section we have defined the gender variable and then made it global so that it becomes we have not defined, we have initialized the memory for gender variable of size 1 byte, and then we made it global so that it becomes visible to the other file, that is lab3 underscore a dot ino. And then we do the same thing for fat and age variable. Our text code is simple. Our text section is simple. We are simply putting a return statement. That's it. Okay. uh, Let me go back on the to the description of the lab and see if I need to explain anything else in this video. Uh, yeah. So you need to what you need to do is that in this task A, you need to simply download, prepare the project, and run the code, and follow the prompts on the serial monitor. Uh, and then when you are done, then show the result to TA to get the points. You also need to comment the code in your files to get additional 5%. When you go to the end of the description, you will see what percentage is assigned to each task.